In this video, we are going to discuss the hash algorithm, which is the after MD5 and seems to be more secure than the message digest algorithm. And that algorithm is known as secure hash algorithm. In short form, it is known as SHA. Now, this algorithm came into the picture in 1995, and National Institute of Standard and Technology uh, has developed it, and it has been published in 1995. Uh, Now, whenever we are comparing this message digest algorithm with the secure hash algorithm, we find that the message digest algorithm is giving the digest of the size of 128 bit, and in comparison to that, uh, the secure hash algorithm is more advanced form of calculating the hash value related to a message, and the size of the hash value or the digest value is 160 bit. So what is a secure hash algorithm? It is going to produce a message digest related to a message of the size of 160 bit, and it is designed in such a manner that it is infeasible, because we want security about that with the help of the message digest which has been obtained for a particular message, we are not able to get the original message, as well as two different messages should produce two different digest value. So just to safer point of side, we adopt secure hash algorithm than the message digest algorithm. That is why SHA is said to be more advanced version of the message digest algorithm. So as far as the algorithm or the steps which are involved in the secure hash algorithm, it includes all those operations which are used in MD5, but besides that, something more, just to strengthen the hash value which is obtained for a particular algorithm, for a particular message. So all the operations are based on the message digest algorithm, message digest 5 algorithm, and a small modification has been advised. Now, in MD5 or the message digest algorithm, the first process was the padding. So what we do in that, we add number of bits, which makes total length of the message 64 bit less than multiple of 512 bit. This operation we used to do in the message digest algorithm, MD5. The same step is also used in SHA1 algorithm. Now, secure hash algorithm has two versions. One is secure hash 1 and another is the secure hash 512, which is more powerful than the SHA1. SHA1 produces 160 bit output and SHA 512 produces 512 bit output. So the padding is being done by adding the number of bits to make the total length of the message 64 bit less than the multiple of 512 bits, as we do in the message digest MD5. Then the second step in the MD5 was to append the length by adding the 64 bit number, and that 64 bit number is representing the size of the original message. The same thing is done in this SHA1 also, that the length of the original message is represented in the form of a 64 bit and it is added after the padding. So now we have original message plus padding bits plus the 64 bit which is representing the original length of the message. Then the third step in the MD5 was to divide the appended message into the blocks of 512 bits. The same operation is also performed in SHA1. So all these three operations, such as padding, appending length, dividing into the blocks of 512 bits, is same as it is whatever is being done in MD5. Now the fourth step is having little bit change, and that changes in case of MD5. We used to take 4 variables A, B, C, D with certain values as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9 A B C D E F, and then F E uh, D C B A 0 9 8 9 8, then 7 6 5 4 3 2 1 0. In this case, in the case of SHA1, we take 5 variables. Instead of 4 chaining variables, we adopt 5 variables. And these variables are named as A, B, C, D, E, where A, B, C, D values are same as we used to use in the MD5 algorithm. But we have added another variable E, so that is represented by a 32-bit number, that is C3, D2, E1, and F0. Rest value, chaining variable value, that is A, B, C, D, it remains same, that A will have the value 0, 1, 2, 3, 4, 5, 6, 7. B will have 8, 9, F, A, B, C, D, E, F, and C will be having F, E, D, C, B, A, 9, 8, and then D will be having 7, 6, 5, 4, 3, 2, and 1, 0. And E will be having C3, D2, E1, and F0. Now, the SHA1 starts from this place with the process block, as we used to do in the process blocks in the MD5 algorithm. Now, in process block, the first step is to copy the chaining variable into temporary register. In case of MD5, we have 4 variables, so we used to store in the 4 registers. In this case, we have 5 variables, so we will be using 5 temporary registers, that is A, B, C, D, E, and we will be copying the value of the chaining variable into these registers. The step 2 in the MD5 in the processing block is to divide the 512-bit blocks into 16 sub-blocks such as 32-bit. So we also do the same process of dividing one 512-bit block into 16 sub-blocks, where each sub-block will be of 32-bit. In step 3, SHA1 has 4 rounds, very much similar to the MD5. MD5 is also having 4 rounds. And each round we have 16 iterations because we have 16 blocks, sub-blocks. But in case of SHA1, instead of 16 operations in one round, we have 20 operations in one round. So it means in MD5 we have 4 rounds, and in each round there are 16 iterations. So total number of iterations are 64. But in case of SHA1, we have 4 rounds, but in each round we have 20 operations, or the 20 iterations. So we have 20 into 4, total 80 iterations. So the difference lies in between MD5 and SHA1 is, the first is using chaining variable, one extra variable has been added, one extra register has been taken, and the number of iterations in one round is also enhanced. Now, as far as the value of the constants are concerned, in case of MD5, we were having 64 constant value given by a particular table. But in this particular case, in SHA1, we have only 4 variables, 4 constant values. Value of t between 1 to 19, matlab t1 to t19, the value will be same. t20 to t39, the value will be same. t40 to t59, value will be same. And t60 to t79, the value will be same. So instead of using 64 different constant values in MD5, we were using only 4 constant values in SHA1. In process P of MD5, we were having 4 processes, 4 different processes for each round. Similarly, in SHA1, we also has 4 processes, and individual rounds will be doing the processing part based on this process values, process equations. And this is one round operation of SHA, single SHA1 operation. And similarly, since it is representing single SHA1 operation, similarly we have to do 80 such operations. So in the very beginning, how it starts? In the very beginning, we were having the 5 variables, 5 registers, which has the values of the chaining variable A, B, C, D, E. First of all, we apply the process P in between B and C and D. So what is process B? Suppose it is the round number 1. So we will apply this process, and this process involves only B, C, B and D. So that is why B, C, D has been taken, and we apply a process on that. Whatever is the value of B, C and D, we apply the process such as AND, NOT, AND, OR, and then whatever is the result, we will be getting the result in the form of a 32-bit. Now what the result of this process is uh, added with the value of E. And then the next step is to take the value of A, make a shifting left hand side, a circular shifting left hand side by 5 bit. Whatever is the value 38, 32 bit is available in A, we shift that value 5 bit left circularly, and then after shifting that value 5 bit left, we add that value with the output of this at this place. Once it is being added, then only we try to add the sub block value into the output. Sub block value is added, and then we add the constant value, and whatever the result we will be getting in the form of a output, that will become the value of A, similar to whatever we were doing in case of MD5. So A has been updated after one round doing this operations. The value of A is updated, the value of B is also updated, and the previous value of A will become the new value of B. The previous value of B, after doing the shifting process, whatever are the number of the bits available, whatever are the bits available, we shift it 30 left. 5-bit shifting, here we are doing 30-bit shifting left side. And after shifting, whatever is the output, that will become the new value of C. And the new value, old value of C will become the new value of D. And the old value of D will become the new value of E. So this is all going to give you the idea that what is happening in single operations of SHA1. I'm going to repeat. BCD is taken, process P is applied, the output is added with E, and then A is being shifted 5-bit left, so it is added with the output. Then we add the first subblock value, and then we add the constant value and update that value with A, and the previous value of A will become B. The previous value of B is shifted 30 times left and then becomes C. Previous value of C will become the value of D, and the previous value of D will become the new value of E, and then it will go into the next operation. So this is the formulation which has been done with the process, that what will be the new value of A, B, C, D, E, what will happen, what will be the value of A, what value of A will be represented by, this value. This is new value of A. What is the value of B? The new value of B is the old value of A. What is the value of C? The new value of C will be the old value of B shifted 30-bit left. What is the new value of D? The new value of D will be the previous value, old value of C will be the new value of D. And the new value of E will be the previous value of D will be the new value of E. So this is how it works. So let us find out that how this new value of A is coming. This new value of A is obtained by adding KT. So first of all, the new value of A is obtained by adding E with the process P. New value of A is first process is to add E with the process P. Process P means BCD. So what is done? E plus process P. And then what is happening? Then add S5. Then S5A. Shifting A 5-bit left. Then add WT. Then add KT. and then whatever is the output. So E plus process P plus S5A plus WT plus KT. What will be the resultant of the value in the form of a 32-bit? That will become the new value of A. Now it has been explained that process P is the logical operation that is happening in between BCD. ST is the circular left shift of 32-bit subblock by T-bit. WT is the 32-bit derived from the current 32-bit subblock. Now, this WT is nothing but it is the 32-bit. The 512-bit block is broken, is transformed into subblocks of 32-bit. So WT is representing that 32-bit. First block, second block, third block, and fourth block. Subblock. Then KT is the constant value which we have discussed. And so the problem is when 512-bit blocks were broken into parts of 32-bit, so we will be getting only 16 subblocks, and we have to make 20 iterations. So it means from W0 to W15 it is available, but we are not getting W16, W17, W18, W19. So W16, W17, W18, W19 can be obtained by this formula, and the remaining this formula is meant for 64 new values, because first time we will be having only 16 values. So next time we have to get to, we have because there are 80 iterations, so we need 64 more values. So all these 64 values can be obtained with this help, with the help of this formula. And the formula says that if t is equal to 16, suppose we want to get the value of W16, so W16 will be equal to W0 XORed with W2 XORed with W8 XORed with W13. When these values are XORed, then whatever is the result, it is shifted one bit left. And then whatever value we will be getting, that will be W16. Similarly W17, similarly W18, and similarly W63. So that's why how we are getting W79. So we are having W0 to W15, but W15, W16 to W79 we have to get, and this value can be obtained by this formula. So this is just the illustration what I have explained earlier, that from 0 to 15 we have the 16 subblocks, because 512-bit block has been transformed into 16 subblocks. So we have W0 to W16, but we don't have W760, W15, W16 to W79 we don't have. So with the help of this formula we can get it. So this is how the SHA1 works. Now we are going to compare the MD5 with secure hash algorithm 1. Now, based on a certain parameter, the message digest length in the bits, in the case of MD5 it is 128 bit, but in case of SHA1 it is 160 bit. How it is 160 bit? Since we are using 5 variables, in case of MD5 we are using 4 variables, and ultimately the final value of ABCD is the digest value. So in case of MD5 we have 4 variables ABCD, 4 registers, and each register contains 32 bit. So 32 bit, 32 bit, 32 bit, 32 bit will be counting as 128 bit. But in this case we are also using another register E, so total value will become 160 bit. So that is why it is 160 bit. Now MD5 requires 128, 2 to the power 128 operation to break, and it requires 2 to the power 160 operations to break. So it is more secure, said to be more secure than the MD5. It requires 2 to the power 64 operation attack to try find 2 messages producing the same message digest. So half of the operation, so 2 to the power 64 operation. But in this case, 2 to the power 80 operations. So again, more secure. Successful attacks so far, there have been reports to attempts up to some extent about the MD5, but SHA1 it is not reported till now. As far as the implementation of the algorithm is concerned, it is simple. MD5 is simple and does not need a large program or a complex table, but it is simple also, and it also does not need any large program. Of course, the computational complexity is more in case of SHA1, but even though it is advisable to use SHA1. So based on this parameter, we find that SHA1 is more secure than the MD5. Now the SHA 512, of course, the message digest size is 512 bit. Message is divided, instead of dividing the blocks of 512 bit, we divide the block of 100, 1024. Base is MD5 and developed after the SHA1. So what is done in SHA 512, that instead of taking padding is done in MD5 and SHA1, padding is done 64 bit less than the multiple of 512 bit. But in this case, padding is done 120 bit short of the multiple of 1024 bit. And then we are going to append the length, and then we are going to add 128 bit with the original message. Divide the input into 1024 bit subblocks. So in that case, we will be having whatever is the total size of the message. It is, instead of dividing into 512 bit block, we divide it into the 1024 bit block. And chaining variable which are used in SHA 512, instead of 5 variables in case of SHA1, we will be using 8 such variables, and each variable will be of the size of 64 bit and are represented by A, B, C, D, E, F, G, H. These are the chaining variables value. And the process block is very much similar. In this case, we have 80 iterations. And SHA 512 has 80 iterations, and each iteration will be using 1024 bit block, and we will be using a constant value from 0 to 79, that is 80. So 80 iterations, so 80 constant values are required. 1024 bit block, it is divided into 16 subblocks, each of the 64 bit. In the case of SHA1 and MD5, we were using 16 subblocks, each of the size of 32 bit. So that is the only difference. And this is the operation, which seems to be more complex than the SHA1, but it is going to give the result in more accurate way. So this is all about the SHA 512.